Hello and Happy New Year! Welcome to the live broadcast of Rocket Lab's first mission for 2021, a dedicated launch for OHB Group. Today's mission will be Rocket Lab's 18th Electron launch, which is why we've affectionately named this mission Another One Leaves the Crust. I'm Ariana Ryan, a quality engineer in the propulsion team.
And I'm Uriel Baker, the Senior Communications Advisor here at Rocket Lab, and it's great to be joining you from our Mission Control Centre here in Auckland, New Zealand. Right now on your screen you can see Electron vertical on the pad at Rocket Lab Launch Complex 1 on New Zealand's Mahia Peninsula as it awaits its scheduled liftoff time of 7:58 p.m. New Zealand time. The launch crew has been on site and hard at work since early this morning to prepare Electron for launch, carrying out a series of horizontal checks on the pad before Electron was raised vertical at around T-4 hours in preparation for fueling with liquid oxygen and kerosene. Before that begins, Electron weighs around only 1,300 kilograms thanks to its lightweight carbon composite structure, but once it's fully fueled, Electron's liftoff mass is closer to 13 tons. With propellant loading complete for today's mission, it's almost time to go to space. We're at about 12 minutes away from liftoff, which is scheduled to hit it very soon, and all of Electron's systems are healthy and operational. However, we're keeping a close eye on the wind levels at the pad, which could see us go into a hold to wait for a better gap in the weather to shoot for.
Vcon LD mission,
LD Vcon,
and confirm VMS system is ready for clock reset.
please stand by. Can confirm.
Copy. And currently holding.
Okay, so as you can see from the clock on your screen, we have entered a hold at T-12 minutes. We'll stick with these gorgeous sunset views of Electron while we wait to hear a new liftoff time.
LD stage mission.
Go ahead.
Just wanted to let you know of another possible concern here. So our LOX tank temperature, we're unable to get the ullage pressure down, so the temperature is climbing. We are approaching our no-go temperature.
Copy that. Moving to LV.
If you're just joining us, as you can see, we're in a hold at T-minus 12 minutes. Those pesky ground level winds are giving us some trouble, but we'll stick with the pad views while we establish a new T0 time.
quick update here from Rocket Lab Mission Control. If you're just joining us for this launch, we are in a hold at T-minus 12 minutes due to the weather. The team are currently working through a new T0 time and will keep you updated throughout the hold.
Thanks for sticking with us during this hold at T-minus 12 minutes. The team are currently monitoring ground level winds to establish a new T0 time. Bit of a fun fact while we wait, tomorrow is in fact the 3-year anniversary of our first orbital mission, still testing. 3 years later, we're knocking on the door of 100 satellites deployed to orbit. We hope to add to that tally tonight.
As you can see, the clock has been restarted with a new T0 of 0726 UTC, and we are at T-minus 13 minutes and 57 seconds and counting.
All stations proceeding with a go-no-go sequence. Looking for your status for launch at this time. Stage.
Stages go.
Avionics.
Avionics is go.
AFTS.
AFTS is go.
GNC.
GNC is go.
VCon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is currently red and tracking at least 50% chance of being red at T0 as discussed.
Copy. Mission management.
Mission management is go.
LD sub.
LD sub go.
Exec.
Exec is go.
Go now, go sequence complete. We're at T-minus 11 minutes, 34 seconds and counting. We're go for terminal count, pending wind conditions being favorable at T0. From this time on, the 3-word hold procedure is in effect. GC proceed with pad terminal checks, sequence 44.
GC copies.
Avionics LD mission.
Go ahead, LD.
Proceed with sequence 45. Avionics terminal checks.
Copy that. Proceeding with avionics terminal checks.
Stage 1 igniter pressures verified. Hydraulic pressures verified. Stage 1 pre-valves open. LD GC mission.
Go ahead.
Pad terminal checks complete.
Copy. Stage LD mission.
LD stage.
Proceed with stage terminal checks, sequence 46.
Commencing.
Alright, so there we have it. That concludes the poll. The weather is still no-go at T0 currently, but hopefully will subside in time for liftoff.
Today's mission will launch a single communications microsatellite procured for OHB Group through OHB Cosmos International Launch Service. The launch is taking place just 6 months from contract signing, demonstrating the streamlined path to orbit that Electron offers our customers. By flying as a dedicated mission on Electron, OHB has control over launch timing, desired orbit, integration schedule, and a range of other mission parameters. After liftoff, Electron's second stage will deliver the kick stage and payload to an elliptical parking orbit. From there, Electron's kick stage will perform a series of burns with its reliable Curie engine to raise apogee and act as a space tug to deliver OHB payload to its precise orbit. Following payload deployment, the kick stage will perform a deorbit burn to lower its perigee. By dropping closer to the Earth, the kick stage will experience greater atmospheric drag, enabling it to re-enter and burn up faster to avoid becoming space junk.
Now, we won't be showing a live view of payload deployment today, so the webcast will end shortly after the kick stage separates from Electron's second stage, at around 9 minutes into the mission. We'll share the news of payload deployment on our social media channels, which is expected to occur at about an hour after liftoff, so keep an eye out there for further updates. Also, a reminder, today's launch is not a recovery mission. We learned a lot from our return to sender mission a few weeks ago that sets us on a strong path to make Electron a reusable launch vehicle. And so this year we will be launching even more recovery missions. The first will be very similar to the return to sender test and will include parachute deployment and splashdown in the ocean to allow our recovery team to validate the successes of our first test with a second set of recovery data. We're excited to be able to tell you more about those upcoming missions very soon.
AFTS is green and enabled for flight.
LD stage mission.
Go ahead.
Stage terminal checks complete.
Copy that.
Another one leaves the crust is the first mission in a busy launch manifest for Rocket Lab in 2021. This year we'll be launching multiple dedicated and rideshare small satellite missions for both government and commercial customers. It's also the year we'll be launching to the moon for NASA with our capstone mission, which will see us use Electron and Photon to transport a satellite to lunar orbit in support of the agency's Artemis program.
We also have 2 new pads to debut this year, so we'll see liftoffs from Launch Complex 2 in Virginia, as well as our newest launch pad, LC-1B, located at Launch Complex 1. And of course, as Muriel mentioned before, we'll be continuing our program to make Electron a reusable launch vehicle, with even more recovery missions planned this year. 2021 is going to be a huge year for our team and customers, but before we kick into the first mission of the year, let's take a look at all the incredible things we got up to last year.
Ignition. 1.
Twenty 2020 was a big year for our team, but we can't wait to make 2021 even bigger, starting with today's launch, of course. We're now at T-minus 1 minute and 52 seconds to lift off, although we will continue to monitor those winds all the way up to T0. The internal flight computer will shortly take over the countdown to launch while our operators continue to monitor Electron systems. So let's hand over now to Mission Control to listen in on the operators' calls during the final seconds to lift off.
Anti-geysering is disabled.
High flow engine purge enabled.
Stage 1 and Stage 2 tanks are pressed for flight.
Water deluge enabled.
T-minus 20 seconds and counting. T-minus 10, 9, 8, 7, 6, 5, 4, 3.
Engine start. Stage 1 propulsion is nominal.
Guidance is nominal.
And with that, another one leaves the crust. Electron has successfully cleared the
Enter to
pad at
ground
Launch
detector.
Complex 1 and is on its way to orbit. We're now at 46 seconds into flight of our 18th Electron mission and approaching one of the
HV
first
better
major
discharge
milestones of
normal.
any launch, max Q, or maximum aerodynamic pressure. This is the moment during launch when the forces against Electron are at their peak. We'll be coming up to that very shortly, so let's listen in.
Approaching max Q. And cleared max Q.
And we just heard the call there. Electron has cleared max Q. The stage 1 burn is performing nominally and Electron's trajectory is looking good.
Stage 1 guidance remains nominal.
40 seconds remaining.
AOS Chatham Station.
Stage 1 propulsion is holding nominal.
Shortly, the 9 Rutherford engines on Electron's first stage will shut down. We call this main engine cutoff, or MECO. Right after that, Electron's first and second stages will separate, and the vacuum-optimized 10th Rutherford engine on the second stage will ignite. Let's listen in on calls from Mission Control.
Stage separation confirmed.
Stage 2 engine confirmed.
You heard the good news there from Mission Control. We've had a successful main engine cutoff, separation of the stages, and ignition of the Stage 2 Rutherford engine. Up next will be the fairing jettison. And there they go. There's clean separation of those halves for the fairing jettison. And one of the reasons for this shiny protective material you might have seen as they tumbled away is to ensure the aerodynamic heating experienced by Electron on ascent doesn't affect the payload on its way to orbit. Electron's second stage is continuing nominally as we approach battery hot swap in the next few minutes, a maneuver unique to the Electron rocket.
For those of you just joining us, we're just about 4 minutes into flight for our first mission of 2021, and Electron is continuing to carry the OHB satellite to its intended destination in a polar orbit. The operations team is tracking no issues, and the burn of the second stage engine is continuing nominally. At the top right-hand side of your screen, you can see the live telemetry data we're collecting on Electron's performance currently. Electron has made it cleanly through its early launch milestones and is now approaching one of its next critical operations, the battery hot swap on its second stage. We'll tell you a little bit more about what that involves close to the time it's scheduled to occur at T+6 minutes into the mission.
A quick check-in, and Electron is continuing well on its journey to orbit. We're now at T+5 minutes into the mission, and all of Electron's systems are continuing as they should. The trajectory is still looking nominal for Electron's second stage.
Beginning to throttle down. Stage 2 guidance is holding nominal, 200 seconds remaining.
We're quickly coming up to battery hot swap on Electron's second stage. Our Rutherford engines are fed by electric pumps, which drain the power of the batteries during flight. Once the first set of batteries on stage 2 is depleted, we switch them out and get rid of the old ones we no longer require. The battery hot swap is scheduled to occur just over 6 minutes into the mission, and we're coming up on that very soon. Let's throw you back into mission control to listen in.
And battery jettison confirmed.
Hot swap successful.
We've had confirmation that battery hot swap was successful on Electron, and second stage propulsion is continuing nominally. We're just a couple of minutes away now from stage 2 engine shutdown and separation from the kick stage. Electron is currently travelling at speeds of over 16,000 kilometres an hour and at an altitude of more than 300 kilometres.
For those of you just joining us on our first mission for 2021, another one has indeed left the crust with a successful liftoff. About 2.5 minutes into flight, we had main engine cutoff, stage separation, and stage 2 ignition. We're coming up on separation of the kick stage about T+9 minutes into the mission. You've got an awesome view of the bottom of stage 2 there on your screens. You'll have heard us talk about this being the vacuum optimized version of the Rutherford engine. What this refers to is the larger nozzle bell. Due to the lower pressure at this altitude, the exhaust gases require a longer bell to match the pressure of the environment as they exit, allowing for full thrust utilization.
Soon the Rutherford engine on the second stage will throttle down before shutting off completely to allow for clean separation of the stages. We call this SECO, or second engine cutoff, and this separation of the stages will place the kick stage in an elliptical orbit around Earth for a coasting period of around 40 minutes or so. After that, the kick stage's Curie engine will ignite to circularize its orbit around the planet before the payload is deployed.
Guidance is in terminal, 25 seconds remaining.
nominal transfer orbit achieved.
And there's the call from Mission Control. The Rutherford engine on the second stage has successfully shut down as planned, and the kick stage has cleanly separated. The kick stage is now travelling around the Earth at a speed of 8 kilometers per second, and what we call a parking orbit. Around 40 minutes from now, the kick stage's 3D printed Curie engine will ignite to position the stage ready for payload deployment. It's thanks to the kick stage's Curie engine that we can provide our customers with pinpoint accuracy for deployment, enabling them to locate and start operating their spacecraft immediately after launch.
Following payload deployment for today's mission, the kick stage will perform a final burn to lower its perigee. That enables it to re-enter the Earth's atmosphere faster and burn up to avoid becoming space junk. As we mentioned before, we won't have video of that or payload deployment, but we'll continue to share updates about this mission on our social media channels, so keep an eye out there. Before we close out today's live broadcast, we'd like to thank our mission partners, OHB Group. We're grateful to have started the year with your team support. And with that, we're going to end today's webcast, so thank you so much for joining us for another Electron mission. We look forward to bringing you many more this year. For the first time in 2021, this is Rocket Lab Mission Control, signing off.